In this video, I'm going to review how to do hypothesis testing with confidence intervals. Um, the first thing we need to do when we're hypothesis testing with confidence intervals is coming up with actual hypothesis tests. To review, and the book does a good job of talking about what these are, but the null hypothesis is the hypothesis we are comparing our alternative hypothesis to. In this case, the null hypothesis is that the population mean is equal to 37. The alternative hypothesis is really kind of a set of values or anything outside of what this null hypothesis is. And so it's basically is the population mean anything but 37. Then we need to construct a confidence interval, which I've shown you how to do in previous steps. We're going to kind of assume, well, generally they're going to be 95% confidence intervals, but I guess we shouldn't necessarily assume that. And then we're going to determine if the null hypothesis falls in the bounds of our calculated confidence interval. And it's pretty simple. It's going to be these three steps. So let's go to the Google Sheets data set. We're going to pick up where we left off in the first video for this module. I showed you how to calculate the standard error. In the last video, I showed you how to calculate a confidence interval, both a 95% and 90% confidence interval based on the normal distribution. And in this video, we're going to talk about the null hypothesis and the alternative hypothesis and use those in relation to the confidence interval to have a hypothesis test. So the first thing we need to do is specify what our null hypothesis is. So I'm going to give three different values, each for extroversion, agreeableness, and conscientiousness. And we're going to say our null hypothesis equals 55. Our null hypothesis is equal to 46. And our null hypothesis is equal to, let's say here, we'll go 54. And then we're going to say our alternative hypothesis in each one of these cases is that the alternative hypothesis is not equal to 55, 46, oops, not 46, and 54. So what we're trying to do when we after we've calculated or created our two hypotheses, our null hypothesis and alternative hypothesis, we construct our confidence interval. But what we're trying to do basically, and is as exampled here, is we're trying to determine if this null hypothesis, the mean of 37, falls in between the lower and upper bounds of our confidence interval. So in this case, our lower bound is 30 and our upper bound is 40 of a 95% confidence interval. So if we look at where our mu, or the population value, or our null hypothesis is, it's 37, which is between 30 and 40. We're going to, in this case, we're going to retain the null, retain the null, or reject alternative. So this is what we're going to believe, is that our null hypothesis is actually true in this case. And so we're going to say we're going to retain the null and reject our alternative hypothesis. Now, this can be contrasted with the opposite case, where now we have the same data. Our lower bound is 30 on our 95% confidence interval, our upper bound is 40, and our null hypothesis specifies that the population mean is equal to 43, and we can see that's clearly outside the bounds of this 95% confidence interval. So in this case, we're going to ultimately reject the null, or accept the alternative hypothesis that the the population mean is something else other than 43. So that's simply what we're going to do. It's actually a fairly simple procedure. So if we go back to our Google Sheets, we have our null hypothesis for each one of our variables. It's extroversion, agreeableness, and conscientiousness. And we have our alternative hypothesis, which is basically it's not equals to our null hypothesis. We're just going to go up, and we're going to first, let's do the result for a 95% confidence interval. And our result is, so if we look at this value 55, does it fall between 52 and 52.76 and 60.18? And what we see is that it does. So our result is we're going to retain the null. Let's go over here to agreeableness. Let's look at the value of 46. For a 95% confidence interval, does it fall between 38.14 and 45.33? We know that 46 does not fall in this interval between these two numbers. So we're going to reject the null. And finally, for this last value, 54, for conscientiousness, does it fall between a value of 53.77 and 61.27? It does fall between these intervals because 54 is higher than 53.77 and lower than 61.27. So we're going to retain the null. All right, so let's do the same thing for a 90% confidence interval. So our 90% confidence interval, we're going to use the same hypotheses, and we're going to say, does 55 fall between 53.36 and 59.57? It does. So in this case, we're going to say we're going to retain the null because it's between these two values. Let's go to the second case. Does 46 fall between these two values? No, it does not. So again, in this case, we're going to reject the null. Finally, for conscientiousness, if we look at 54, does it fall between 54.38 and 60.66? It's just outside of it. It's just below 54.38. So in this case, we are going to actually reject the null, which is different than the decision that we made with a 95% confidence interval. So that's it. That's how easy this process is. You're basically construct your hypotheses based on your research question of interest, your null hypothesis and your alternative hypothesis, and then you basically see if the null hypothesis falls within your calculated confidence interval or if it falls outside of it. If it falls within the calculated confidence interval, you retain the null. If it falls outside of it, you reject the null. In the next video, I'm going to show you how to actually calculate p-values to perform hypothesis testing based on the normal distribution. It's somewhat similar and a related concept to this. You end up having the exact same decision in terms of rejecting or retaining the null when you calculate versus p-values versus using the confidence interval, but it's just a slightly different way to make a decision about the null versus the alternative hypothesis.